Here is my video for the third question and our walkthrough and exam question prep. Okay, so it shows, figure 1 shows the apparatus used to investigate how the current through a thermistor depends on the temperature of a thermistor. So the thing is like a thermistor, okay, and the question is, which of the following is the correct symbol for a thermistor? Now, if we can't remember, but I can, so the thermistor is this one. Okay, this one's a thermistor, so we've got to give it a tick here. Okay, this one is an LDR, a light dependent resistor, and this is a variable resistor. That's a variable resistor. Okay, so that is question 1, part A. Sorry, 3A. Question 3, part B. To get the range of results, hot water at 60 degrees centigrade, that's important there, was poured into a beaker. The temperature of the water through the thermistor were then recorded as the water cooled. The results of the investigation are as shown in figure 2, and here is figure 2. So this graph is figure 2. So we've got current in amps, and in our equations previously we might have we've got I to represent that, and this is temperature in degrees Celsius. Okay, so we're looking, and I can see before I look at the question that as the temperature increases, the current increases. However, it's not a straight line increase, so there is a change. So it must be variable. So the resistance is varying. So suggest 1, now that's for 1 mark, so I'm going to show you that's for worth 1 mark over here. So suggest one way in the investigation could have been changed to give a wider range for temperatures. Okay, so we could have, so to get that 1 mark you might say use hotter water. Okay. If you used hotter water, we're saying we'll give a wider range. It would have started up here. Okay, so that's a wider range. Or, okay, we could have added ice cubes to maybe to bring this temperature down further this way. That both ways would have done it, but only one of them gets you the mark, okay, because it's only worth 1 mark on this question. So that takes us to part 2. Describe how the current through the thermistor depends on the temperature of the thermistor. Okay, so we would say current increases as temperature increases. Okay, so next says use figure 2 to determine the current through the thermistor at 40 degrees Celsius. So that's 40 degrees C. So what we're going to need to do there is look back to find 40 degrees C. So if we go back over here, find where 40 degrees C is, that comes up here. And we move up along the line to here. Okay, and then it goes in along this line over here. If we have a ruler, it'd be much better. Okay, and 0.02 amps. So what we can see there is 0.0. Don't forget that second naught to 0.02 amps. So then it says at 40 degrees C, the thermistor has a resistance of 250 ohms. Use your answer to part 3, 0.2 amps, and the resistance of the thermistor to calculate the potential difference across the thermistor. Okay, now, so this is making us understand that we need to use V equals I times by R. Okay, so V equals I times by R. So we said that 250 equals the resistance. Okay, and we've got that 0.02 is equal to our amps, which is I. So then our answer, V equals 0.02 times by 250. Okay, so V equals 0.02 times by 250, which equals 5 volts. So our answer here is 5 volts. Now, this brings us back to our last question, okay, in this section, okay, and the potential difference across the thermistor stays the same all through the investigation. So the potential difference of the voltage stays the same all throughout the investigation. What conclusion can be made from the results in figure 2 about the resistance of the thermistor as the temperature of the thermistor decreases? Okay, now if we go back to what we were looking at, what we mentioned a minute ago, so let's go back to look what we looked at. We said that the resistance clearly is changing, and now if V is constant, so if V is constant, okay, and the graph looks like that, let's go back to where we are, okay, so we've got a graph where we've got temperature in degrees C here, and we've got current in I here, and we've got this going on here, where V is constant, and we've got the equation V equals I times by R, okay, where that stays the same. So if that doesn't change, if I increases, so if that doesn't stay the same and I increases, okay, the resistance must decrease. However, the question, if we look carefully, says what conclusion can be made about the results about the resistance of the thermistor as the temperature of the thermistor decreases? So if we look in the opposite direction and say conversely, so if I goes up, R goes down, if that's the same. If that stays the same, if I goes down, R must go up. Okay, so the answer here must be that because I is going down, R must increase. So the resistance increases.